Hi, good morning to everyone. We are Guiomar Sánchez López and María Jesús Rubio de Inglés, and we're coming from the Institute of Earth Science, Guiomar. The aim of our PhD is the study of the reconstruction of the North Atlantic Oscillation for the last 2 millennia. Guiomar works is focused on how the North Atlantic Oscillation has modulated the limnological behavior in 3 Spanish alpine lakes. Here on the right, the picture of one of them. And I am working on the same purpose, but in Azores Island. Here on the right, Azul Lake. But what is the North Atlantic Oscillation?
The North Atlantic Oscillation, formerly the NAO, is a climatic pattern which mainly rules the variability of winter precipitation and temperature on Europe. It is associated with change in the westerlies across North Atlantic onto Europe, and it controls the path of the storm tracks. It is characterized by a spatial dipole of 2 pressure anomaly centers, one in Azores Island and the other in Iceland. And it has 2 phases, one positive and one negative phase. And during the positive phase, both pressure centers are reinforced and they move to the south. So this phase tends to be associated with warm and wet condition in the north of Europe and the opposite in the south. And during the negative phase, the weather conditions are the opposite. Both pressure centers are weaker, and this phase is associated with a cold and dry condition in the north of Europe and wet condition in the south. And all of this is translated in interannual and interdecadal oscillation of the NAO. And now the question is how we can achieve a reconstruction of NAO from lake sediments.
So the first step is the core extraction system. Here we have different devices. For example, it doesn't work. The gravity core that can be thrown from a boat. The floating platform that was the system used for Azul Lake, and laying on the ice platform that was a system used for alpine lakes. The next step is the coring party, which is followed by the physical, biological, and chemical analysis. Once we have all these proxies, we can mix them with the instrumental data. And then we have all the tools required to make the reconstruction of the climate. And now Guiomar will show us a bit of her work.
Okay, the winter now will be reflected in lake parameters, in that case on ice phenology of Peñalara Lake. And hence, using a simple correlation analysis, we determine how it's transmitting the NAO signal to ice phenology. And this is explained in the diagram of conceptual model. In our latitude, during the negative phase of NAO, precipitation and snowfall increase and temperature decrease. So more snow will be accumulated on ice, and the ice cover will last longer due to the isolated effect of snow. And during the positive phase of NAO, there are the opposite weather condition, and less snow will be accumulated on ice, and the ice cover will last shorter. And all of this will control the input and the characteristics of the sediment. Finally, using a Bayesian model approach, we can reconstruct the NAO. That is Thomas Bayes, an English mathematician who provides the mathematical expression of the Bayes theorem. And I'm going to explain that with an example. A, you have the flu, and B, you have a headache. So we know the probability of having a headache when you have the flu. In other words, this is the conceptual model, and is how it's transmitting the NAO signal to sediment in the present. So using the Bayes theorem, we can know which is the probability of having the flu if you have a headache. In other words, this is the NAO reconstruction, going from the sediments, the analysis of the sediments in the past to reconstruct the NAO. And now María Jesús is going to explain her works.
Thank you. Okay, Azul Lake is located inside Sete Ciudades Caldera, an extinct volcano in Azores Island, exactly in São Miguel. Atmospheric patterns such as the North Atlantic Oscillation can provide us the things to create the tropical storms. These tropical storms can pass through Azores Island, increasing precipitation and gusty winds. These heavy rainfalls create enhancement the erosion in the caldera walls, making a greater input inside the lake. This greater input changes signal of physical, biological, and chemical proxies. In turn, these proxies can be compared with the instrumental data, giving us the possibility to distinguish between the normal sedimentation on the lake and the depositions made by these heavy rainfalls. Once we have all of that, we can reconstruct the tropical storm intensity in the past. But can we go further with the reconstruction? For that purpose, we are going to use the molecular analysis. The reconstruction of the temperature can be done with the chemical composition of the archaea membrane, the precipitation using the leaf walks, and the human impact using the fecal esterols. All of that is going to give us the trends and the abrupt changes in the past, and then we can reconstruct the climate. We hope that you like this presentation, and thank you very much for your attention.